Okay, we're in the section now, the materials for exercise number 8. Again, if you look at this, it says Wells chapter 7. They have examples, exercises, and related stage code. Certainly not going to read the text to you. What I do want to encourage you, though, is to certainly go to, if you have the text, go to the section. You notice that sections are always going to look the same. The only difference is the number. So this is going to be the material for section 8. Just to remind you, my name is Ron Bannon. If for whatever reason you need to reach out to me, my email address is Bannon, that's B as in boy, ANNON.US. Okay, so I always say every section is the same. For example, there's contents. I'll scroll through that. There's examples, and then there'll be exercises. All right? The intent of this thing over here, again, is not to read this thing to you. Hopefully you're reading it. And the people that have access to this are the prison mathematics project participants. What does that mean? Incarcerated individuals that are interested in learning, administrators of the program, mentors, security, whatever. They all have access to it, all right? So they have access to the PDF. Now, of course, when I scroll through this, a lot of people say, well, I want access to it. It's not published yet. When it gets published, people get access to it. I'm starting to think I'm going to publish it as a PDF. I don't think it's going to be printed out ever because it's just too long. And I might publish it right through Dropbox, all right? I'm not sure I'm there yet. So this one over here, it's talking about symmetry. This is something that's really not done in algebra anymore, but I'm hoping you have some comprehension that there's symmetry, and symmetry is an important thing to be looking for, all right? So they talk about it, and they talk about cyclosymmetry, and they certainly do examples with it. They talk about applications of it. And the bottom line is that, you might look and say, well, I wonder, why they're talking about symmetry. It's an aid to understanding things about algebra. So let's talk about those things, and they'll be done through example. All right? So over here, my claim over here is this is a cube problem. Now, certainly somebody goes, oh, it's an easy memorization problem. I can remember how to cube that. Or, I will say this, if students want to do this, they say, oh, I'm just going to multiply it together, and they got A plus B plus C, and they put it down 3 times and say, I'm just going to multiply it. I'm not really concerned about learning about patterns. But I want to encourage you, though, that you probably should have some idea that there's patterns to the problem. For example, just looking at it, I know there's an A cubed in it, a B cubed in it, and a C cubed in it. All right? And then I'm going to talk about this stuff over here as being sort of like, if you looked at these terms over here, I would clearly see that there's an A squared B in it, a B squared A, B squared C, C squared B, C squared A squared C. Now someone says, how are you basically doing that? Well, let me just go through one of them, A, B. All right, A, B. Now I'm going to claim each of those terms has 3 separate orderings. You'd see that if you just simply multiplied it out. So that's why there's a 3 here. All right. Now this guy in the end, I know there's also an ABC there. All right. So I sort of taken care of all the combinations. And my trouble now is I want to determine what the M is. I'm not saying it's difficult. I just want to determine what the M is. All right. So the way to do that is, one way to do it is simply just set A, B, and C to some simple number. So what I did is I'm doing this. I'm saying A equals B equals C is equal to 1. Now someone says, could I choose 0? You could, but if you chose 0, it would just say 0 equals 0. It wouldn't tell you what M is. But right now, if I plug in ABC is equal to 1, I'm going to say it should be a very easy computation. I want to go through that with you, though. So if you do A plus B plus C, and A, B, and C are 1, you get 1 plus 1 plus 1 is 3, and 3 cubed is 27. All right? So let me do this. 1, 1, 1. That's 3. Super simple. Then when you get over here, well, what's nice about 1? Each one of these terms would be 1. Every single one is 1. Why is that? 1 squared times 1, 1. 1 squared times 1, 1. Every single term is 1. How many terms you got? 1, 2, 3, 4, 5, 6. And 6 times 3 is 18. So someone says, well, gee whiz, do I know what this is over here? And you don't. All you know about that is A equals B equals C is 1, so you would get M there. So we have a really simple equation to solve. I'll write that down for you. 27, and 3 plus 18 is 21, plus M. I'm hoping you're starting to realize that M is a really simple number now. What is it? 6. So what's the expansion? This is the expansion over here. All right? Let's do the next one. All right? And then, kind of looking at it, it says, this expression is symmetrical with respect to x, y, and z, and of the second degree. I do see that. I see it as a second degree polynomial. And it is symmetrical with respect to x, y, and z. Okay? So I claim that certainly if you did that and you looked around, you'd get something pretty simple. Right? You get something like this over here. Again, it might say, I'm just going to multiply it out and figure out what that looks like. But we're saying it's going to look something like this. My only problem is I don't know what the m is. All right, so we're going to look at that. And what I'm going to determine is, same thing we did before, but we don't have a, b, and c now. We have x, y, and z. So I would look at that and I say, well, let's try x equals 1, y equals 1, and z equals 1, and see what we end up with. All right, now, certainly when I do that, I want to point out, I am claiming that this thing here is equal to that thing there. So I'm going to look at the left-hand side and do that. So if x equals y equals z equals 1, what would you get for the first term? Let's take a look at it. You get 1 minus 1 minus 1, which is just simply minus 1, but minus 1 squared is 1. Now this is symmetric. We're expecting the same thing for the next, but let's go through it. 1 minus 1 minus 1. Still minus 1. When you square that, you get 1. Plus. That third term, again, it's symmetric. What do you get? 1 minus 1 minus 1. What are you going to get? Minus 1. That squared is 1. Let's go to this side now. Let's see what you get. You would get 3 times, 1 squared plus 1 squared plus 1 squared is going to be 3. Plus m. Now, what's nice about the 1, these are really easy to do. You get, 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. So what do you get? You get 3. Let's keep going through this. What do you get next? 3 equals 9 plus 3m. Now, I believe you can do that by inspection, but I want to go through it with you. I'll take 9 from both sides. You get minus 6 equals 3m, and m equals minus 2. So my expansion, I know, for this expansion over here, and I'll write that down for you now, is going to be 3x squared plus y squared plus z squared. And now I know that m now. And what's the m going to be? Minus 2. So I'll just put down minus 2xy plus xz plus yz. I realize there's doubting Thomases wondering if that's true. And again, what I want to claim is that it's really not bad to multiply it out. Right? It's really not bad to multiply it out. So if you want to multiply it out, you can. I'm not opposed to it. All right? I'm not opposed to you multiplying that out. All right, let's take a look at this one over here, that cube problem again. And again, I'm looking at it. It's definitely symmetric with respect to A, B, and C. It's of third order. It's third degree. And I'm expecting to see something like this in the end. And again, these are the patterns that are being mentioned in the text. Algebra is concerned with a lot of patterns, but again, if you're doubting Thomas in this one, what I'm going to say is, maybe a little handwork and multiply it out. You'll see that. Okay? So let's take a look. And what am I going to do? Same thing I did before. All right, whoops, let me go back up here. I'm going to set A, B, and C equal to 1. And let's talk about this one term at a time. So I'm going to say over here, sorry about that, I'm going to say that this thing here would be equal to this thing here, regardless of what numbers I'm choosing. So why are you choosing 1, 1, 1? It's easy for me. So let's do that, one term at a time. So I'm going to do this first, and what would I get? 1 plus 1 plus 1, so I get 3 cubed. I'll write this down for you. Plus, what do you get for the next term? 1 plus 1 minus 1, which is 1 cubed. We'll do that later. Then what do you get? Well, I'm on the third term now. 1 plus 1 minus 1 is 1 cubed. And then the last term is going to be 1 plus 1 minus 1, 1 cubed. Let's do the right-hand side now. What are you going to get? And I'll be careful about this. It's 2, and you get 1 plus 1 plus 1, which is 3. Again, we choose 1 because it's easy. Then you get 6. And again, I'm pointing out this over here. 1s are really easy to do because each of those terms would turn out to be 1. So you get 1, 2, 3, 4, 5, 6. I'll write that down for you. Plus m, right? And a times b times c. If a, b, and c are 1, it's just simply 1. So let's write this down. On the left side, you get 27, 28, 29, 30. I'll write that down. On the right side, you get 6 plus 36, which is 42. Now again, I believe by inspection you can do that, but if not, subtract 42 from both sides. But m, no matter what you do, is minus 12. So I know the answer now. What's my answer going to be? Well, that expansion produces, and again, it's up here, where the m is minus 12. All right? This is written down here for you. All right? Let's keep going. Let's keep going. Ooh, there's nothing left. What's left to do? Make sure you read the section. Make sure you can do the exercises. All right? Now, certainly when you're doing the exercises, a lot of it has to do with symmetry. And look around. Try to read that, make sense out of the symmetric properties of problems. All right? It's important you do that. And again, you may not appreciate everything that's being done with symmetry, but symmetry is something that we look for. All right? So look for the symmetry and do the problems. There's not many problems over there. Now, someone might say, I want to do these problems differently than you're doing them. We don't mind. You do them the way you like to do them. Don't think you have to use symmetry. We just think symmetry might be helpful. But don't feel like you have to use symmetry to do these problems over here. They're kind of saying, that you should use symmetry. There's a lot of problems there. I realize that, by the way. A lot of problems. Give it a shot. All right? Also want to mention to you, there is some SAGE over here. What's SAGE? It's a computer algebra system. We abbreviate that with just the three-letter CAS. We say CAS. So it's an acronym. The acronym stands for Computer Algebra System. Why do I like SAGE? It's free, but more importantly, it's used all over the world. I can't imagine any place that's taking mathematics seriously not having access to SAGE. SAGE is an important product. All right? So what do you do when you go to the website? This is the website. You need access to the internet. You could either download the application if you know how to install software on your computer, or you could use the interactive web-based application. And some of the earlier videos, I showed you that. All right? I also want to point out there's code given here. You can type it in and think about what's given over here. Reset, sort of give you a clean slate. When I take ABC is var, I'm saying that make them a variable. And then I say expand, and basically just expanding things is all I'm doing. And you may wonder why I'm doing that. It has something to do with what you've done in the homework, all right, or in the exercises here. And certainly go through that. Again, I know I'm repetitive, and something about being a teacher. Teachers tend to be repetitive. But again, my name is Ron Bannon, and I'll point that out. It's right up here. And my email address is this, B as in boy, ANNON.US. A lot of times, I'll be honest with you, I get overwhelmed with email, and I might, just get so backlogged I don't answer you. So what do? If it's really important, email me back, and I'll try to get back to you. I'm usually pretty good, but sometimes I get overwhelmed by the amount of emails I'm getting. Thank you for paying attention.